Hello, welcome to another episode. Today we're going to talk about MCP servers. In 10 minutes time, we're going to walk you through how to set them up, what they actually do, and what kind of services they provide. So without further ado, let's get after it.
So first I want to go over the general architecture of how you lay out your MCP servers. So first you have the host or client. This is something like Warp or Claude Code that you're using as a plugin or as an ADE, which is what Warp is. The next piece is going to be the orchestrator. This is your configurations for the connections to these MCP servers. It kind of tells your IDE, ADE, how or where to interact with these different MCP servers. The next piece is going to be a local MCP server. This is something you could code or develop and run locally on your machine to allow it to find your local file system, set up Java code, or connect to Postgres. And also the ability to define when and where these systems are authorized to run or access different parts of the computer. So it gives you a lot of capability to restrict how much access it has. And then there's external sources, things like Jira and GitHub. And the power here comes in when you allow your application to be able to read from Jira and then auto-generate code and then generate PRs against GitHub. So imagine the power there. An agent could technically do the work of a developer for bug fixing and resolution. But before we get to any of that, let's take a look at Warp 2.0. We can manage the Warp drive through this little icon up here in the upper left-hand side. From here, we can see the MCP servers, and we can also see other things like prompts, workflows, things like that. But today we're focusing on MCP server. So in here, if I click on the MCP servers, you can see I have 5 different MCP servers defined. Everything from Playwright, Context 7, Docker, GitHub, they're all in here. So if we look back at the diagram, we're working within the orchestrator. That's where all the configurations and the registries happen. Now remember, we're in Warp 2.0. In Claude Codes, it's a little different, but from the Warp AI, we'll be working within the configs and defining out our external MCP servers. So again, in the diagram here, we have a couple external ones, identified Jira, Postgres. Now let's take a look at the configurations for the MCP servers within the Warp environment. You'll notice here that you have the ability to start and stop different services, which is very important from the standpoint that you don't always want to use all of them. You have certain ones that you want to use at certain times, and you don't want to pay the price of having the LLM go out and utilize these servers when there's really no need. And each one of those times that it utilizes it, it costs, either in tokens, requests, or other scenarios. So the more you can limit the use of these, the better. And that's where having the ability to start and stop these is very powerful, and it's a cost savings. So now let's go take a look at how these are configured. This is an example. This is GitHub. This is an MCP server, JSON. Here you'll notice the command says Docker. That just basically means that the container that the MCP server is running is in a Docker container. You'll also notice that I blacked out my access token on purpose. But let's go back and go ahead and start it up, and you'll be able to see the commands. Here you can see that the indicator shows that this is now running, so it connected up. Now we can take a look at some of the commands that are available through the MCP server. We can do things like search the code base. And we can do things like create a branch, which is really powerful if it's making code changes. We can also create a pull request, allowing a developer to double check the work that's been done. And we can allow it to create issues. So imagine a situation where the system is told to go through the code base, find to-dos, and auto-generate issues that can then be worked by another agent. Now let's take a look at another one, Playwright, which is a UI-based design server that allows the ability to control different browsers and UI components. Things from Chrome to Firefox, And it provides the LLM the ability to go in and then test against these browsers in real time, which is very powerful, so that the LLM or the agent can then make assessments of what it's seeing in the UI and then offer up changes or even find bugs in the system without you having to do anything. Hugely beneficial to have something like this, but it is expensive from the context of token or request utilization. So at this point, we've mostly discussed external MCP servers, but you also have the ability to do local MCP servers, meaning you can generate your own, which provides the capability for you to then limit access or define access, as well as being able to query a local database that you might have in a Docker container. All of these types of things become available to you through local MCP servers. So since we're talking about local MCP servers, I'm going to go ahead and ask Warp to go ahead and create one for me. Like, why not? So with that in mind, here we can see that I've asked it to generate an MCP server for the virtual garage that sets up a global MCP server for the Postgres. I wanted this global so that I could demonstrate that an MCP server actually runs external to your project. Once it's done setting up, it will fire up the server and allow me to access via configuration. You'll notice here on the last line that it is actually firing up the server, the JS server script, and it's running it locally. So now that that's up and running, we can now configure. So here I'm going to go ahead and add, and at this point I'm going to walk through adding a new MCP server that I have freshly defined. So in this case I'm going to call it Postgres, and the command is an npx, which is the way it was set up. And then I'm defining out the arguments, which include the connection string. So once that's completed, I should be able to now start the Postgres MCP connection, the configuration to the connection. That doesn't mean that the server's running. It just means that my MCP server connection is there. So now that it's up and running, we should be able to now ask specific natural language questions to the agent. So in this case, I'm going to say list the tables, something simple. And you'll notice that as it processes, the agent's going to go, okay, this command could probably be handled by this tool. Do you want it run here? And of course, our answer is yes, I would like to run this one using my MCP tool. And as you can see, it actually listed out all of the tables associated with this database. This saves us because it's not having to do a lot of requests back and forth through an LLM and costing money. So here I'm just going to say, well, okay, great. Show me all the records in the vehicles table. And I can do it again with very natural language as opposed to trying to look up the SQL itself. So as you can see, as you get more and more complex within these calls, the more you can rely on the agent to identify what and how the SQL should look. So here you can see that it's returning all of my content from within the table, and a nice bulleted list, which is kind of nice. It's easy on the eyes, I guess. So yeah, with this, you can now see that I've got my own MCP agent running locally. I can access it directly from within the Warp UI. And you can imagine how much power this gives you from the standpoint of being able to restrict or allow the MCP servers to access your system.
So now that you've seen exactly how to set them up, how you can utilize them even locally, how you can attach to ones that are external, you can see the power of some of this. The beauty of it is that you can mix and match these things. You can turn them on, turn them off. They're amazingly powerful. So I look forward to hearing from you in the comments below. And as always, like and subscribe, and we'll see you on the next video.